My name is Erin Gingerella. I'm with the Connecticut Pre-Apprenticeship and High School Training Program. I'm here with 3 instructors from UConn. We have James Mahoney, Scott Zinke, and Alex Bernier. We thank you for joining us for the Intro to Asphalt Quality Control Technician program. We'll be here for about 8 weeks every Friday. If there is a Friday that for some reason you can't do, I am recording these and I will be posting them to our website. But this is just another great opportunity to see another job or career opportunity for you guys in the future. This program is funded by the Connecticut Department of Transportation. If you want to just fill out the attendance sheet, that's perfect. If you're in a group and you can't, that's fine. I can just touch base with your teachers to check in and see who is here. And they can email me. Jim, do you want to?
Sure.
Go.
I can lead it off.
All right.
Welcome, everybody. As Erin said, my name is Jim Mahoney. I work at UConn, and I have 2 of my colleagues with me here today. And so what we do is we have an asphalt lab that does research on asphalt, and we do training as well. And so we're here to talk about the asphalt industry and how it can be a beneficial opportunity for you guys as a potential career path. As Erin said, we're going to be here about eight Fridays in a row. Well, like I said, I think there's one for spring we have one Friday off because of everybody's on vacation that week. But we're going to talk about this. We're going to give you some background. I think there's some good opportunities for you guys to explore if you're interested. This is a career that does not require a college degree. You have the opportunity of moving forward on this. We've seen people go very large place, or not large places, but move up very quickly through the ranks. If you're willing to work and you're willing to put in the hours and the time, this is an opportunity for you to find a career that is well paying. It's stable. It can't be farmed out to anybody else. It's got to be done here. You can't ship it overseas. And so there are a lot of opportunities in this. And there's always a need for people in the asphalt world. You don't realize how many people are involved in an operation to pave a roadway, but there are a lot of people involved in that. And so that's an opportunity. Like I said, this is a great opportunity for you guys, and we want to give you some information and hopefully spark your interest in it. So this is a program, obviously, between the DOT, UConn, and the apprenticeship program, where we are looking at this to try to help you guys out to explore this opportunity. We are the CAP Lab, which is where we all work at UConn, is a research and training operation focused on hot mix asphalt, the liquid asphalt binder, the black gooey stuff, the aggregates, that's the sand and the stone, as well as we do stuff with concrete, as you would Portland cement concrete. And so, yeah, we're located in stores. We're not on the main campus. We're a couple miles off, but we are out there as well. So go ahead, Alex. So what's the asphalt industry that we're talking about here? What we're talking about here is these are the folks that produce the aggregates that are used to make our roadways. There's sand, there's stone in it. And these aggregates are used for paving. They're also used for concrete. They're used for a lot of different construction opportunities. And so we have the production of the aggregates. We have the actual production of the pavement materials themselves. That's where the red dot is swirling around. That is a mix plant right there. And so that is where all those materials are put together, and out comes the pavement as we know it. And it's actually placed out in the field. So there's a lot of hands that are involved in this to get it from the point where it's a ledge, where it's a solid piece of rock, to the point where it is actually being placed on a roadway and being compacted, and you're actually able to drive over it. And then beyond that, there's also the maintenance operations. So we place this material, and then we have to maintain it over the years to ensure that it is going to hold up and be able to provide a reasonable driving surface. So there's a lot of work that goes into this. Go ahead, Alex. So just some interesting facts about asphalt. It's the most widely used construction material in the world by at least a factor of 10, if not a factor of 100 times more than any other material in the world. Asphalt's almost 100% recyclable. Not too many things in the world can claim that, but asphalt is essentially 100% recyclable. So therefore, it is a sustainable material. Another thing that people don't really guess is that the actual carbon emissions from asphalt production are much less than they are from actually producing concrete. The concrete production to make the cement, there is a lot of energy that goes into creating that material. And so when you're producing that, you have to burn a lot of fuel to do it. Asphalt, there's a lot less fuel consumed to be able to produce that. Even though we're placing it at about 300 degrees Fahrenheit, the amount of energy that's required is much less. Asphalt's also a naturally occurring substance. You can actually find it in rocks and things like that. It is not some manufactured man-made product. It is actually a naturally occurring substance that's been used by humans for thousands of years. So it is not, everybody views asphalt pavement as the detriment to the world, but in actuality, we're actually just using all natural materials in there and we're producing our roads. Now, how does this affect you guys and why is there opportunities in this? Well, the DOT in Connecticut spends more than $120 million every year maintaining their roads. That doesn't include all the 169 towns that are in the state. And so a lot of money is spent on asphalt and pavement maintenance over the course of every year. There's a lot of work in this area. There's a lot that needs to be done. And to give you an idea on the volume of material that we're talking about, the DOT itself buys typically over 1 million tons of asphalt each year in the state of Connecticut. We're a small state. We're the third smallest state in the country. So there's a lot of asphalt produced and a lot of it is a lot used. So there's a lot of material, a lot of money involved in this. And again, like I said, it can't go anywhere. It can't be farmed out. This is not going to be automated. You're not going to be displaced by a robot anytime soon. So there's a good opportunity here. Go ahead, Alex. And it's important to understand that our roadways have to be in good shape so that because our economy is dependent upon that. Because you've all driven on roads that are in bad shape, bumpy, a lot of potholes, things like that. That's always a problem. And so if we want to be able to get goods and services moved with minimal delays, we need our roads in good shape. And that helps to translate to a healthy economy. And so imagine if we're so used to being able to order things from Amazon or whomever and have them delivered within a day or two. Well, that's all because we have a good road network and we need to keep that road network in good shape so that all these products and goods can be delivered and can be utilized in a timely, efficient manner. We also want to have good roads because it promotes safe driving. People swerving to miss potholes and things like that a lot of times cause crashes on our roads, which is obviously not good. We want to avoid that. And just to give you a little more detail on how many miles of roads there are in the state, the DOT in Connecticut maintains over 4,000 miles of roads, and municipalities maintain 17,000 miles of roads here in Connecticut. And we're a tiny little state. We're about a rectangle that's about 100 miles wide and about 50 miles tall. And so there's a lot of roads and there's a lot of money that's spent on this stuff. And the infrastructure is really important. This is a picture from way back when, in the 1800s, when cars were just being introduced. And you can see one of the big problems on a gravel road is it gets muddy and that kind of thing. You can see there's chains that are actually on the little narrow tires there to try to help the vehicles propel themselves through the mud. Obviously, that's a big problem. And then the first vehicle that ever went coast to coast in the United States, there was a bet that was made between two people who owned cars when they first were being introduced. And they bet who could drive from Seattle, Washington, or somewhere out in Washington to New York State and who could get there first, New York City, essentially. And so it took them 91, the fastest person did it in 91 days. Now, if you wanted to drive from here to California, you could do that in 3 or 4 days. But it took them 91 days to go from the West Coast to the East Coast. So it is an important thing, and it takes a lot of money and a lot of time to do that. So, what is asphalt that we're talking about? Well, when you're driving it, what you're seeing is really a combination of sand and stone held together by the black gooey stuff, otherwise known as asphalt binder. And so, when we produce all this stuff, we're mixing these things together, we're adding the asphalt binder to it, and we're creating a mixture known as hot mix asphalt. And that's what our roads are paved with. And so we want to make sure that we're blending those things correctly and that we're putting it down and we're getting good quality materials out there so that the roads will last. Because as taxpayers, we don't like to pony up money to have a road paved only to have that road fall apart in 4 or 5 years and full of potholes and things like that. So we want to make sure that we're getting the biggest bang for our buck that we can. And to give you an idea what a pavement consists of, it's about 90% sand and stone, another 5% asphalt binder, and there's about 5% air voids in there. So that's what a pavement consists of, and that's what we're trying to make sure of when we're doing quality control to make sure that this blending is being done correctly. Go ahead, Alex. So the paving operations summary, we have to heat up our materials so that we can blend them together. We need to dry out those materials as well when we heat them. We then load that material into trucks so that it gets out to our project so it can be placed. And then we deliver the material and then it's placed and it is actually put down by a paver and it is actually compacted so that we try to squeeze out quite a few of the air voids so that the pavement will last longer and that we get good compaction on it. And then we allow it to open to road, or we allow the road to open to traffic, and therefore we roll forward that way. So there's a lot that goes into this, and there's a lot of opportunities here. I don't know when I'm supposed to drop off, Alex, so just jump in when the time comes. Scott?
Oh, this is where I come in? Okay, no, sounds good. Okay. All right, so it's no problem. All right, so let's talk a little bit about the nuts and bolts then of how we actually get this material onto the roadway to the point where you can drive over it, where traffic can actually be applied to the roadway, and how we get it to last for years and years, you know, potentially and hopefully that's the desire. Up on that banner up there that says liquid asphalt plus sand plus rocks. Okay, that's the material that Jim mentioned goes into what the pavement actually consists of. Okay, we can't just bring all this stuff out onto a job site and mix it up and put it down. It's actually got to get run through what's called the central mix facility, and there's multiple different types. On the left-hand side, where Alex's cursor is right now, what you're seeing is what's called a batch plant. Later on in this course, you'll learn the difference between a batch plant and over on the right-hand side, what's called a drum plant. They both essentially do the same thing. We put rocks and asphalt and we use heat. We mix them all up, and what we get out of it is the hot mix asphalt that gets delivered to the job site. They both put out the same thing. It's just that there's a different mechanism. There's different mechanisms and different functions to get there. But nonetheless, both of these types of plants, this is really interesting. These are interesting slides. Both of these types of plants, what they do is the same exact thing. They put out, the inputs are the same and the output is the same. It's just the way that they function to put out that HMA is a little bit different. And these things have evolved over time. It's pretty cool to look at old images like this, not only for HMA, but also, you know, old original concrete mixers and things like that. From the primitive, you know, state that it was in back in the 1800s and early 1900s to where we are right now, which is closer to the images that Alex showed you in the previous slide. So these are facilities that are dedicated to, again, combining those things, the asphalt binder, liquid asphalt binder, and the sand and the rocks, and then using heat to dry those materials out and ultimately heat them up to get them to mixing and compaction temperature. That's good, Alex. Okay, and so there's a lot of different elements to these production facilities. If you take a look at what's going on with respect to how the stone and the aggregates and everything moves through the facility, most of the actual production is dealing with the aggregate, with the stone, with the sand, and the fact that it has moisture in it, and that it needs to be dried out, it needs to be heated up to really, really hot temperatures, you know, in excess of, right around 300 degrees or in excess of that. And it's also got to be combined to the right gradation. We can't just have a bunch of sand and stone thrown into the mix. It's got to be the right proportions and so forth that are prescribed with a design process. And if we don't get the correct proportioning, then we're going to end up with an HMA pavement that gets compacted into the field that simply won't last. It's just not going to last. So we design these things, and we are dependent on these production facilities. You're looking at the outside of that asphalt the aggregate delivery system of the plant right now. So if we don't get the correct proportions, if that plant can't be depended on to put everything together the way that we need it, we're simply not going to get a roadway that lasts. So what you're looking at here is, and again, we're going to get into a lot more detail about the actual production of the HMA, but once the material is produced, it's going to be loaded into trucks, and it can be loaded into a truck out of what's called a pug mill at a batch plant, or it may be loaded from a silo at a batch plant or at a drum plant. But nonetheless, there are these huge tanks. What you're seeing right here is what's called silo loading of a truck. And generally when these haul units, and I'll use those terms interchangeably, a haul unit and a truck, I'm going to refer to as the same thing. What you're seeing here is that mix that's been manufactured being loaded in its hot state into a truck. And what happens with that mix is ideally, and what'll happen is it'll get loaded in what's called a three-step or three-drop process. And what that does is a couple different things. It's going to distribute the load in the truck in a better manner. And it's also going to create and you'll see this in a couple slides, create a situation where when that truck body lifts up and that material dumps out of the body of the truck, it's going to tend to break together and force a little bit of reblending of that mixture. So we don't end up with what's called mixture segregation, which is another aspect of this that we're going to talk about later on in this course. And so that truck that you're seeing just leaving the plant is headed out into, it's going to haul that mix out to a paving project. Alex. Okay, what you're seeing on the left-hand side, all right, is the multiple drops that you saw get dropped into that haul unit at the pavement production facility. Something that's unique about these haul units is, if you can imagine, we have to have this stuff it's got to get produced, it's got to be in a hot state in order to, get thorough mixing and so forth. And it's also got to stay hot enough until we can actually get compaction, right? It's got to stay hot. So there's a few different things at work here. There's the sheer mass of all of that material. What you're looking at is in excess of 20 tons of hot mix asphalt in the back of that haul unit there. And so asphalt tends to retain heat very well. It's not perfect, but nonetheless, it retains heat very well. But there's a couple other different things that play with these haul units to try to retain the heat until we get to the compaction portion that we're going to talk about in a little while. What you noticed in the previous video was there was an automatic, well, it's not automatic, it's controlled, but there is a tarp that comes over the bed of that haul unit to try to retain some of that heat, so all the heat's not lost, okay? And there's also what are called heated bodies, where the exhaust, okay, believe it or not, is channeled through the bed of the truck, and that exhaust, it's vehicle exhaust, and so it's hot. And so that creates a little bit of heat. It's a mechanism by which we can, minimize the amount of heat loss from that material, so that when we get it to the job, it's still hot enough to be able to get put through the paver, ultimately put down and compacted in place to the point where we want it. And so there's a number of these different haul units. As Jim mentioned earlier, it takes a lot of different people to pave a road. It takes people all the way from, folks that are going to be running the plant and operating at the production facility to truck drivers are the next people in line. They have to take this material out to the project in order for it to be paved. And it says here that the number of trucks is dependent on the total round trip haul time. That is true. And it's also, dependent on how much material is going to go down that night. Ideally, you have enough trucks to feed the paving process in a continuous manner. But it's just another testament, to how many people it takes to run a paving project. You may have as few as 3 or 4, all the way up to as many as 20 or more haul units on a single paving project. And each one of those haul units has its own driver. So that's just another indication of the number of people that it takes for this process to take place. Good, Alex. So once that material gets on site, what you're seeing here is the hot mix asphalt being loaded into what's called an MTV. MTV stands for Material Transfer Vehicle. The Material Transfer Vehicle serves a couple of different purposes. Okay, number one, it serves to remix that material. All right. If you can imagine, by the time a truck leaves the production facility until the time it actually would dump material into a paver on site, the outer shell of that mass of material is going to be in a colder state than the inner portions of that pile. And so in order to remix this material, so it's in a all in a uniform manner, many states, and Connecticut is one of those states, have required the use of one of these material transfer vehicles. And you're going to see a slide later on that shows you the difference between in the actual temperature, the uniform temperature between a material transfer vehicle's use versus a project that did not use material transfer vehicle, in which the truck dumped directly into the paver. Another thing, and this is a good image here, what you're seeing is the truck dumps directly into the material transfer vehicle. And what you'll notice is that the material transfer vehicle does not touch the paver. That's called contactless paving. And with contactless paving, what that does is it creates a situation whereby the screed, where everything comes out, that I'll talk about in just a minute, maintains its elevation. If we have an end dump situation, which is not ideal, where the truck dumps directly into the paver, the screed tends to lift up a little bit or dip. And that creates, every time a truck comes into contact with the paver, that is potential for a bump in the pavement, which is not desirable. We're looking for a smooth, dense, and uniform pavement. And so the material transfer vehicle is part of that operation, and it's a really important part of that operation. Okay, Alex. Okay, these are images that have been around for quite a while. This is one of the original projects I worked on with Jim when he first brought me on board. On the left-hand side, what you're seeing is the result of what's called end dump. Without a material transfer vehicle, the haul unit takes that material from the production facility directly to the paver, backs up, and the paver eventually touches it, and it pushes the haul unit forward as that haul unit dumps material into the paver. And what you're noticing here with those cold spots on the left-hand side, you're seeing temperature differentials close to almost 100-degree temperature differential, which results in a problem because you're not going to be able to get the same level of compaction in those cold spots as you are in the surrounding mat. What you're seeing in that specific area is the beginning where one load ends and another load begins, and that's called a cold spot because that material has to ride its way, all the way through the paving process, right? And that's the coldest material that's been sitting in that paver hopper until by the time it gets out to the end of the screed, it creates what's called a cold spot until the hot material from the next load makes its way through the paver. And so that's a very common thermal image that you'll notice from load to load through a thermal camera on a paving project if you're not using a material transfer vehicle. On the right-hand side, what you'll notice is there's a lot more uniformity. And the difference there, the reason that you're not seeing any cold spots is because that material was put through a material transfer vehicle on that specific project. There was a lot of remixing as a result of that MTV. And so you end up with a situation where if you're trying to find the load, the beginning of one load and the end of the previous load on one of these projects, you really can't see it. And that's because that remixing, the remixing properties of the MTV has caused that, that temperature uniformity that is very desirable. That's going to give you a much more smooth and uniform pavement because you don't have those cold spots. Okay, Alex. And so this is showing you the contactless nature of the delivery of that HMA pavement material to the paver hopper itself. Now, what you're seeing on the left-hand side, that big bucket-looking thing that is inside the paver hopper, that's called an insert, and that holds the pavement material as it's delivered from the boom on the MTV. Now, it's important. One, really important thing is that this is a constant. Ideally, this paving project would be fed in a constant manner so that paver never has to stop over the course of the paving operation, unless it has to pull back or if it's at the end of the project. But hopefully it doesn't have to stop and wait for a truck. Hopefully it doesn't have to stop for any other reason than it needs to back up and tie in another pass and so forth. And so if it never has to stop and it never has to come into contact with a vehicle, ideally that screed will stay at the same elevation and you'll end up with a much more smooth pavement at the end of it. So this is just showing you a video of material being delivered from the MTV into the insert, okay, that is chained into the paver hopper. Okay, so that's the paver that you're seeing directly, and then on the left-hand, excuse me, on the left-hand side, that's just the boom from the MTV that is causing that's handling that delivery. Okay. Excuse me. What you're seeing here is what's called an application of tack coat. Okay, tack coat, it says here, is an emulsified liquid asphalt project. That means that is a liquid, it's hot, and it's asphalt essentially blended with water that gets sprayed onto the roadway surface prior to the paver. All right, it goes in front of the paver so that when the paver puts this material down, it helps to bond it to the existing surface. And that's really important. What happens with the tack is that the water evaporates, it's hot. Okay, and the water evaporates out of it, just leaving an asphalt membrane or an asphalt coat or film on the existing roadway surface. And the intention there is that the layer that we're paving, okay, the wearing surface that we're putting down, is going to be bonded to the existing surface below it. And that's important because your whole pavement thickness, okay, from the wearing surface where the wheels go, where the wheels on a vehicle go, all the way down through the bottom layer of pavement are all intended to function in unison. All right, and so you don't want, one layer acting independently of another layer. We want this whole pavement structure acting, together to resist the effects of that traffic loading. One layer, the layer that we're putting down in this case, if it had to act alone to support the load of traffic, it's not strong enough to do it. It's dependent on the layers underneath it, and so good bonding between layers is crucial in order to have a long-lasting pavement. Okay, so what happens with the material as it's delivered to as it gets delivered to the paver? All right, there are what are called drag slats, and it pulls the material to the back of the paver. And there are augers that help to spread that material out, okay, to the width of the paving pass. And then ultimately there's a screed. Okay, the screed is what leaves it in a uniform manner. What you're seeing, what's left directly behind the paver, is an uncompacted, okay. It's uncompacted, but nonetheless, it is smooth and it's uniform, so that when the compaction unit, so the rollers, when they come hit it, they can compact it. That screed consists of a couple different things. There's a screed plate on the bottom that helps to smooth everything out, right? Because the pavement is essentially being left in a pile in front of the screed. And the screed helps to basically it screeds it off. It screeds off that head of material, and it helps to leave it so it's flat and it's uniform in a manner that the rollers can hit it. Another thing that's going on with that screed, there's couple of other different things that I might mention, is they are heated. All right, they can be heated, especially which is crucial at the beginning of a project while all of the equipment is still cold. Okay, so that way the pavement doesn't stick to the screed itself, which is going to can potentially cause a tear in the mat. And it's also equipped with a vibrator, and that vibrator helps to give a little bit of extra compactive effort prior to the application of the rollers. And so ultimately what you end up with prior to the application of the compaction equipment is an asphalt mat that is approximately somewhere between 70 and 80% compacted. So what you're left with is a situation where the rollers that can come in and finish that compactive effort, and you're left with a roadway that is smooth, dense, and uniform ideally. Okay, and so this is what the mat looks like directly after the paver. This is before what's called a breakdown roller hits it. A breakdown roller is typically going to be the heaviest roller that you have on site, right? And as far as the work that the rollers do in achieving density, the highest level of densification that you're going to get comes from that breakdown roller. And I think we have an image of a roller, right, Alex, coming up next? Yeah. And so there's going to be generally two or in a lot of cases, 3 rollers on a project to achieve the final level of density. The first roller is going to be called a breakdown roller. And that's where you're knocking that uncompacted material down to the point of compaction. There's potentially an intermediate roller as well, all right, that continues that compaction process. As the pavement cools down, we're continuing to densify it as much as we can. And then ultimately what's called a finish roller. A finish roller is simply intended to smooth out any, I'll call them imperfections in the mat before it finally is cooled to the point where we can't do anything with it. Generally speaking, these rollers are going to be decreasing in weight from breakdown to intermediate to a finish roller. A finish roller can be, as small as 2 or as many as 5 tons. An intermediate roller, can be a lot heavier than that. And some of the breakdown rollers that we see are as much as 20 ton double drum rollers, and they can function in either a vibratory mode or what's called an oscillating mode. And those modes are intended to give us the highest level of compactive effort while the material is still hot, so we can achieve the highest level of density prior to the application of traffic. Okay, so this is, I believe what you're seeing here is a breakdown roller. Okay, and you'll notice the steam coming off of, what's that, Alex?
Right onto it.
Yeah, and so what you'll notice is the steam coming off the roadway. That roadway, the paver just left that area, and it's leaving behind a hot mat that is ready to be compacted. The steam is coming off of that mat because the roller utilizes water. Okay, there's an even sheen of water over the roller wheels, and the reason for that is to cause a cooling effect on the steel that will keep the pavement from being lifted up or sticking to the roller. Okay, and ultimately, the goal, if everything went right, and it takes an awful lot of work and an awful lot of people and awful lot of effort and everything to go right to get here, we end up with a smooth, dense, uniform pavement that is going to support the traffic loading that we're going to apply to it, and that is also going to provide for a smooth, comfortable ride to the motoring public and hopefully last for a long time.
Thanks, Scott. Yep. So that's, the production of pavement and what pavement is. Now I'm going to talk a little bit about why quality of pavement is important. We're primarily giving you the background here for being quality technicians, whether you're doing a role as an acceptance inspector or a quality control inspector. And we'll get into a little bit more of the difference between those two, but know that acceptance is whoever's buying it, where the money's coming from, and the quality control person is working for whoever is making the product, right? That's usually a contractor. But the quality we're talking about with a pavement refers to environmental distresses or traffic distresses. And the term, we use the term distresses, that's like an engineering term because it's not just cracking that is a problem for our pavements. There's friction concerns, which is it's a huge one. You don't see it. So most motoring people in your car, you don't think about that all the time. But if the road does not have friction, you will know it very quickly and it will be very dangerous situation actually. So friction is one of those distresses, as well as rutting, which we've all kind of experienced near intersections where you've got deformed pavement. Anyway, I'm getting ahead of myself. Sorry, got slides for that. Environmental loading is one of these first factors. And the reason this is so important for us with pavement is because asphalt, the glue we use, the black sticky stuff, it changes its characteristics depending on the temperature outside. So when it's really hot, the asphalt is actually more flexible. And when it's really cold, it behaves more like a solid that could be cracked. And you might have experienced this just in your lives. I don't know if you've ever been in a parking lot on a very hot day and you've stepped on crack seal and noticed it's kind of gushy. That's the asphalt becoming more soft or having a lower viscosity. That's the technical term for it, which we'll get into in another session. But the other example is in cold weather, that's when pavements are prone to thermal cracking. Or excuse me, load-related cracking at low temperatures. So from an environmental standpoint, there's thermal cycling, which has to do with the nighttime and daytime cooling in the pavement. We've got water, which is always a problem for any type of infrastructure we build, whether it's a house, a bridge, a dam, right? Obviously with water, but pavement itself can be damaged by water. Then we've got freeze-thaw cycling, which is related to water, right? If there's just freezing without water, pavement, it will actually last longer, like in the Midwest of our country. And then finally, snow and ice, right? Even though there's forces when that freezes in the pavement, there's also distress that happens when we plow it, right? There's certain types of plow blades we can change up to protect the pavement a little better. But in certain cases, you might have seen roads being scraped up or damaged by just maintaining our roads in the wintertime. So thermal cracking is the expansion and contraction of the pavement from a daytime to nighttime situation. And if asphalt never oxidized, meaning it aged or became more brittle, this wouldn't technically be a problem for us. But pavement, the black sticky stuff, the asphalt itself, degrades over time just because it's a naturally occurring material, right? If you put a banana outside, you can't expect that in 10 years it'll still look like it did when you put that banana outside. Asphalt is similar because it's naturally occurring. So it degrades, and when asphalt degrades, it becomes more brittle, which means it's more likely to snap or crack. And eventually this thermal cycling from daytime to nighttime over and over and over again, affecting the pavement and actually changing its shape, will eventually lead to cracking. So pavements that are not designed or built correctly usually crack more. You'll also tend to see thermal cracking more on lower volume roadways. And one of the crazy reasons about that causes this is on a higher volume road, the vehicles driving over it are actually helping drive the pavement down into place and make it less likely to have these thermal cracks. And the way we all as pavement people know a crack is a thermal crack is when it goes across the pavement. When it goes down the wheel paths, that's usually going to be something that's more caused by traffic. So freeze-thaw cycles, what we're talking about is when something freezes and then it warms up. That's happening quite a bit these days, right? It's actually ideal for people who make maple syrup, but for those of us who maintain roadways, it's less than ideal. So what happens here is we've got micro cracking or small voids in our pavement that have been left over from construction or have progressed through time. Water gets in there, freezes, and drives them apart over and over and over again, right? And the more that happens, the wider the cracks get and the more rapidly our pavements degrade. I think that's all I want to say on that slide. But here's a prime example of one of these freeze-thaw distresses, right? We've all probably hit one of these recently or driven around them. I was elated yesterday because our town did some pothole repair on our road, which I had been driving around to avoid, right? These are not great to hit with your cars. And actually there's, I think it's like $60 billion estimated annually in distresses caused on people's cars by poorly constructed pavements in our country. Maybe it's 6 billion, 60 sounds high. So water, I mentioned, right? It's not just the freeze thaw aspect of water that can damage pavement. Because asphalt is naturally occurring, it has a lot of chemical challenges that we deal with in our industry. And as QC technicians, we aren't directly making decisions about the chemical additives that get put into the asphalt liquid, but asphalt and water both have these magnetic forces, and there is a chance with certain aggregates that the water can make the asphalt peel away from it. We call it moisture susceptibility or stripping. And what happens here, it might be hard to see depending on your screen, but there's actually stone in these samples that have no asphalt on them after this testing that was done. And that's an example of a moisture susceptible pavement. This type of failure will happen in 3 to 5 years if you're not protecting for it, but there are additives that people can put in. So that's one of the tests that like a QC or a technician would be testing to make sure the materials aren't going to be susceptible to this. And then traffic loading, which is probably the easiest thing to conceptualize, right? The more that goes over a road and the heavier those things are, the worse it is for our structures. That's why if you happen to drive on the Merritt Parkway versus I-95, right, in general, the conditions of that roadway are going to be better because there's no truck traffic, or there shouldn't be truck traffic. But trucks are exceptionally more damaging to roads than our cars. And we'll get into a little bit of why that is later on, but the heavier a load is, the worse it is, right? That's kind of intuitive. It's how snowshoes work in a sense. We distribute our weight more and you stand up on the snow more. So when we have higher loads, that can manifest as rutting, which is actually the deforming of the pavement. It's like dealing with Play-Doh or clay, right? You push on it and it doesn't come back. It actually changes its shape. That's called a plastic deformation. The other way traffic, so rutting is extremely dangerous because water can pond in those ruts and cause hydroplaning, or in the weather like we have today, it can cause freezing. And right, in either of those situations, cars are not going to be in control by the operators. So the other way that traffic damages roads is with cracking. And this is a really extreme example of fatigue cracking, which is when you take something and you bend it over and over and over and over and over again, and finally it cracks. I don't know if anyone's ever done that with plastic, but even if you're bored, maybe in class, I know most of you don't get bored in class, but if you take your pen and you bend it over and over and over and over and over again, you would eventually crack it here. And that's because this type of material, the same thing would happen with steel, with many types of materials, but that type of failure is a repetitive load. And even though one load, right, if I bend this pen once a little bit, it's not going to break, but it's hard to see. I'm deflecting that a little bit, right? If I do that over and over and over again, maybe 1,000 times, it will break this pen. And the same thing happens to pavement. When it's designed, we account for a thickness to assume a certain amount of traffic, right? Like, well, this is a highway between Hartford and Boston. We're going to assume that based on these populations, this many people will be driving through. What if a massive city appeared in between them, right? That's going to change the traffic load, and it's going to cause this type of cracking sooner. So quality control is really important. It's intended to ensure that the asphalt being produced and placed meets specification requirements. And what we mean by that is it's a contract. Whenever a contractor, which is where that term comes from, right? It sounds very similar. Whenever a contractor does work with a state or a town, there's a written contract between them saying, I will do this, you will pay me that. And there's a lot more than just those simple words, including how to make and place the asphalt. And so, for example, in the state of Connecticut, there's a document called the 816, which is the state standard specification on construction. And there's probably, what would you say, Jim, 100 pages dedicated to placement of bituminous pavement plus that liquid asphalt. So
Yes.
there's 100 pages of rules. Oh, sorry.
You asked me a question, so I answered.
Thank you. Yeah, it's about 100 pages of rules that everyone's agreed upon on both sides of the aisle, whether you're an acceptance inspector or a quality control inspector, that you need to know, is this meeting it? Is this not meeting it? And what are the rules, right? And we're not going to be, by the end of this course, you're not going to have those 100 pages memorized, but it's something where, 5 or 10 years into a job in paving, you would have a pretty good handle on your set of those rules. There are certain people who only focus on the aggregate. Certain people only focus on the liquid asphalt, right? There's a lot of different, we've mentioned over and over again, for any single paver truck, there's probably close to 24 people supporting that, maybe more, depending on the size of the project. So if the quality of the product is not maintained, there are going to be penalties levied against the contractor, the company doing the work, or they don't get caught, and the taxpayers, not caught isn't the right word, but it might not be identified, and taxpayers will pay a penalty, right? Because the road fails. So it's not great when work is done poorly and the payment is full, right? There's supposed to be a change in compensation. If you go to buy a car, for example, I don't know if anyone's had this experience lately, like buying a used car and it has 4 flat tires, right? You're going to want to reduce the price of that car to help you buy new tires. That's sort of what's happening with these contracts. The state will say, or whoever's building this road will say, okay, we understand that this pavement was built slightly less than we were hoping to, so we're not going to pay you the full price. That's what a penalty is. The poor quality of the material results in premature failure, which is dollars lost, right? When we invest as a town, as a state, as taxpayers, putting that money forward, we expect a certain amount of life out of the pavement. And one really wild slight aside to that is in our state, the average age of a state road, right? There's 4,000 miles of state road, as Jim mentioned earlier. The average age of our roads are about 9 years old. If you go to a place like Arizona, where they don't have a wet freeze winter like we do, the average age of their pavements will be dramatically older. I know there's pavements out there in the southern part of our country that last 30 to 50 years without issue. So we have a really hard time in the Northeast, but we all like to live here for some crazy reason. So bad premature failures for us are 3 to 5 years. If we get 10 to 15 years out of a pavement, that's a success where we live. So quality control technicians serve to identify potential problems with sampling and testing. And the details of this class are going to be, what are those samples and tests? Here's a picture of someone in a very old lab doing very similar testing to what we do to this day. A lot of it hasn't changed, which is kind of cool, but there are new techniques and new technologies that help make it easier for sure. Like this is a scale over here, right? It probably took a lot longer to weigh something than it does today, where we set it on a digital scale and numbers are displayed that we write down. So very different approaches, but very similar measurements being made. Kind of interesting. Quality control technicians, and we covered this in the first session for those of you who may have participated in that. Quality control technicians test the quality of the materials against recognized standards. What we're talking about is a test protocol, a procedure. And they also perform visual inspections to make sure that material does not have defects. So there's two aspects to this. One simple example of running a test protocol is taking its temperature. As we've discussed, temperature is really important for that material arriving on site. If it's too cold, we're not going to get density. So a standardized test is, did I take that temperature, right? You could actually take a temperature wrong and make a wrong decision. So we all need to agree upon how we take those temperatures. And then visual inspection kind of speaks for itself, but there's a lot of experiential knowledge you will get, and we'll present a lot of those problems in this course, as well as what to look for specifically when that mix is not being produced right or being placed right. Quality control technicians work with their company specifically. As I mentioned, a QC or quality control person works for a contractor or a producer. So they're working with their company to troubleshoot problems, prevent problems, and react and respond and change the process to make it better. A quality control technician works with an acceptance inspector to make sure that the materials are meeting those requirements. So on a state project especially, there will always be a state inspector and a contractor's QC inspector, and they work together, right? They're measuring the same thing, but they're looking at it for different reasons. This work may be done at an asphalt mix plant or on site. When you're on site, you're going to be checking the samples. You're going to be making sure the temperature is good, making sure the compaction is proceeding properly using something like a non-destructive density gauge. This one is a nuclear gauge, but they make performance quality indicators, which are non-nuclear. Again, we'll get into a little bit more of those in another session. And they'll work with the roller operator. So because this is super temperature dependent, depending on the season, depending on the thickness, and depending upon your equipment, every time we construct something, it's going to be slightly different. And it's really up to the QC who's in the field to help make sure that that happens properly. The rollers could be too close and they might actually damage the pavement if it's too hot while they're trying to get too much compaction. Additionally, if they spread too far out, they might not get enough compaction before it cools off too much. So there's a sweet spot. So much with pavement, I liken it to Goldilocks and the Three Bears, right? Too hot, too cold, just right. That happens over and over again with a lot of the things we're talking about. So another thing you might be doing is visually inspecting for defects. This person here is causing segregation and low density at the joint. You also might be cutting cores and submitting paperwork. There is a lot of, not an extreme amount of paperwork, but every time you run a test, right, you have to record it. You can't just keep it up here. So there are standard forms we're all filling out. I thought I was running a little behind, but that's pretty good timing. Okay, so we can, if anyone has specific questions, feel free to ask them or type them in the chat. That's my timer. No, was that a bell for a class? I'm not sure.
So let's see. We have a quiz. Aaron has put the link in the chat. Let's see. Aaron, I believe you guys get the output of these things.
Yes. So it's just a 15 questions, easy. You can do it now or you can do it for homework. I am going to post the video from today. So if you, have questions and you want to go back to it, feel free. And there is a question in the chat.
Yeah.
When is there a layoff in Connecticut?
There are layoffs. It depends on, as you proceed up in a company, when you become more valuable to them as your knowledge grows, then they're less likely to lay you off in the winter. Your first year or two, yeah, you'll probably get 3 or 4 months of time off where you're able to collect unemployment. And I know that sounds like a weird thing to say, that's a plus, but you usually are laid off, and it's a seasonal layoff, so you don't have to go out and looking for a job or anything like that, because it's anticipated that you'll get your job back in April-ish. So usually late November, early December, through the heart of the winter, and then as spring starts to roll in, you will usually be called back. And then as you get a couple of years into it, you usually are not going to be laid off anymore if you are doing a good job for that company, and because they want your knowledge there all winter to do some of the tweaking that they need to do all winter. So
there are also some of the companies in our state are very big in a sense where if you would want to work and you'd be willing, I'm sure they could ship you south for the winter sort of thing and help out on projects in other parts of the country.
Some of the more senior QC folks at some of these companies don't get laid off. Not every single person gets laid off. So from a QC perspective, if you are brand new, like Jim said, perhaps, that's something you could look at, but a lot of the more senior QC guys, not so much, especially with some of the smaller companies. If a lot of these companies only have 1 or 2, maybe 3 guys or people doing QC, people have to be available to handle mix design stuff that, material evaluations and all this stuff that has to happen in the off season, and there's personnel required for that. And so it's not every single person that's doing QC that gets laid off.
There's
So
another. Were you gonna?
Yeah, there was another question here about how they work themselves up to delivering with a truck. The biggest thing on that one is you have to get your CDL license. And in order to get your CDL license, you have to go through a training program. So like you could go to like the New England Tractor Trailer Training School and get the training there. But you have to go through an accredited program to be able to get your commercial driver's license to be able to drive trucks. I used to have one, but I let it lapse because it was a really big pain to keep it because I wasn't driving anymore. So trucks, that is. So that would be how you could get into that aspect of it.
You can also drive those trucks for companies. Like most producers employ a certain amount of truck drivers, but then they also hire individuals who own their own trucks, and they're kind of like a small business. So it's a good opportunity for someone who wants to work for themselves.
Yep. Yeah, because companies actually get benefits for hiring small businesses. So there are some credits that they get for that.
And there's always need for truck drivers. We're always short.
So I realize we're running out of time here in our hour, but we appreciate everybody tuning in. We're going to go into a lot more detail on a lot of this information in the coming weeks. So hopefully we continue to see your smiling faces every Friday, and we will take it from there. And we will review the quiz on next Friday. That'll be the first thing we do, and then we'll take it from there.
So the link is here in the chat. And if you leave class and you're not sure where to find it, you can find it on our website, ctpahstp.com. If you just look under additional programs, you'll find Asphalt, and then the quizzes will be listed there along with the videos. So thanks everybody for joining us, and we hope to see you all next week.
Thanks, everyone.
Thank you. Have a blessed week, everyone.
Yes, thank you. You too.